All right. So I got asked to do this problem or one like it, because I won't do the exact problem, but I'll do one very similar. And then I was also asked by the same person to do this. And then once that request was made and I sent out that I was going to have a session today, I got people asking me, well, can you do one like this too? And can you do one like this too? So what I want to point out to you, when I send out a practice exam, they're kind of thematically organized. So you shouldn't see four problems there. Those are all the same problem. They're all the same problem. They're four of the same thing designed to give people a workout for computational fluency over the exact same skill. And then there will, and anytime you see on a practice exam that the instructor is giving you four of the exact same type of the problem, you should expect to see one like that on the exam. But that's the first key here. That's not four. It's not four different things. It's four of the same type of problem. They're conceptually identical. So if you know how to do one of them, you know how to do all four of them. The other thing that got asked today is, will I send out a key for the practice test? And the answer is no. I will never send out a key for the practice test. They slip out into the wild here and there, but not by my design. So I don't want you to see my work solutions on a practice test. And the reason I gave it to you so early, which was what, a week and a half, 2 weeks ago, is to give you time to nibble away at it. And then you've got the Remind app, which means you can take a picture of your work and shoot it to me and say, what's this look like? How is this looking? Does it look like I'm doing this right? And I'm happy to give eternal feedback on work that you've done. But I don't want to work them out myself and just send you my work solutions. That's not the purpose in my mind of a practice exam. It's for you to work. These are all things that showed up in the homework. This gives you an opportunity to work on them. And you all have smartphones and can send me pictures of stuff. And if you send me pictures, I'm going to tell you whether you're doing it right or wrong. And if you are doing it wrong, I'm going to tell you what you're doing wrong. But you've got to ask me for that feedback. So I'm not going to send out a key for the practice exam. But I do want you to notice they really are the same problem. Every one of these has a denominator that isn't one. That's the big theme. And so the question is, how do you deal with it when you have a denominator that's not a one showing up in the problem? What's the most efficient way to deal with it? So number 3 was asked about. So I'm not going to do number 3, but here's one right over here that's just like number 3. So if I look at something that's got this type of setup, the idea is I could waste my time distributing the 1/7 into the parentheses and the 2/5 into the parentheses, but I would be wasting my time and making the problem more difficult than what it needs to be. So the big idea here is that anytime you have a denominator and you're working on a single variable, which this is, it has only a p, a single variable linear, which this is because all of the p's are only to the first power. Anytime you're working on a single variable linear equation, you can just get rid of the denominators if you've got an equation. You can say, hey, look at the denominators I have. What are they? They're 7 and 5. What's the least common multiple of 7 and 5? Which is just another way of saying, what would the best choice of a common denominator be if for some reason I needed to find one? And in this case, the answer would be 35. 35 is the smallest number, positive number that 7 and 5 both go into. So if you just take and multiply both sides of the equation by 35, it's going to simplify to an equation that doesn't have a denominator anymore other than the number 1. So once I do the multiplication, I did the same thing on both sides, so I'm in good shape. 7 goes into 35 5 times, and 5 goes into 35 7 times. And then you just simplify. 5 times 1, and I have a 7 times 2. And notice I don't have a denominator anymore other than 1. I can always write everything over 1. So at least 1 is a denominator. But in this case, that's the only thing that, now it's just a linear equation with nice integer coefficients. So what do you do next? You distribute the 5. 5 times 4 minus 5 times p plus a 4 equals distribute the 14. 14 times p minus 14 times 4, which is 40 plus 16 is 56. And I've got like terms, so I can choose to simplify those if I want to. So I have 20 plus 4. And now I need to get the p on one side, and I need to get everything with a p on one side and everything that doesn't have a p on the other. So I'm going to choose to put the p's over here on the right-hand side. So I'm going to add 5p to both sides. And then I'm going to get the 56 off of here, so I'm going to add 56 to both sides. And now I know what 19 p's are, but I need to know what 1p is. So I'm going to divide by 19 because 19 divided by 19 equals 1. And 80 over 19 is already in simplest form, so I would stop. So the big idea is I could choose to distribute the 1/7 and the 2/5 at the start, and I could work through the entire problem with fractions, but I don't have to. That's the big idea, and was one of the big ideas in one of the first homework assignment. So if I'll do one more. Like I said, they're the same. In each case, you look at the denominators and you say, what's the common denominator going to be? What would a common denominator be? What would a common denominator be? What would a common denominator be? And you pick the best choice and you multiply both sides by that number to clean things up. So this one has 3 things equaling 3 things. So I set up the same format, 3 things equaling 3 things. So it's a little bit different in terms of the numbers, but it's the same problem. So you look and you say, hey, well, that's a lot of fractions. I would prefer not to have to deal with the denominators. And because I know I'm going to multiply both sides by something to clear the denominators, I'm leaving myself space here to put the number I want to multiply by. And you look at the 2, the 4, and the 5, and what would the least common multiple of those 3 numbers be? What would the best choice of common denominator be?
20.
Yeah, so you just multiply both sides by 20. And then I'm going to show way more work than what I would usually show. So the idea is you've got to distribute the 20 into each term, which you could do in your head. But if I didn't do it in my head, then I would just go 20 times the p over 5 plus 20 times the 2p minus, I need to move this out of my way a little bit. That's ugly. Minus 20 times the 1/2. And again, these are things we could have done in our head without writing it explicitly, but I'm trying to show detail. So 20 times the 3/2 of a p minus 20 times the p over 4 plus 20 times 3 seems like I should just put the 60 down. and then you simplify things a little bit, right? So you step over here and you say 5 goes into 20 how many times? 4 times. 4 times p is 4p plus 20 times 2 is 40p minus 1/2 of 20 is 10. And over here, 2 goes into 20. 10 times 3 is 30p minus 20 divided by 4 is 5. 5 times p is 5p plus the 60. And then it's just a nice linear equation with no denominators to have to deal with, and it's easy at this point. You just combine your like terms. And then decide which side do you want things on. Subtract 25p off of both sides. Add 10 to both sides. If I add 10 to both sides, I'm going to get 60 plus 10 is 70. And if I subtract the 25p off of both sides, what am I going to get? 21? No, that's not going to be 21. 34, it's going to be 15, right? Ooh, can't do arithmetic today. 30, 14, 19, it's going to be 19p. And then divide both sides by the 19. So anyways, that's the big idea. The big idea is nobody asked me about problems 1 and 2. Why did nobody ask about problems 1 and 2?
Because they didn't have fractions.
Because they didn't have fractions, right? Nobody asked about problem 1 and 2 because they didn't have fractions. And the big idea is I can always eliminate those fractions if I have an equation by finding the least common multiple and multiplying through it. And then I put it into a position where I can more easily deal with it. I don't have to deal with the fractions because I clean them up. That's the concept. That's the big idea. I can make it look like problems 1 and 2. And then once I make it look like problems 1 and 2, it's easy. So then the next question I got, because once I said I was running the session, people started throwing the questions out after the 2 o'clock deadline that you have for questions. And guess what? Guess what one popped at me next? This one. And this one right here, 14. And why did 14 get asked about?
It has an inequality.
Yeah, I don't think that's why it got asked, because
Fractions.
X is on the numerator.
there were inequalities there that didn't have fractions. Oh, but that one has a fraction. But conceptually, is it going to be any different than these? It isn't. Nobody's asking me a question about the problems that don't have the fractions. So the concept is identical when it's an inequality. Is I can eliminate the fractions if I don't want to have to deal with them, right? The only thing different with an inequality over an equality in terms of your solution steps is if you multiply or divide both sides by a negative, you have to reverse the direction of the symbol. But every other algebraic move is the same as it is for an equality. It's all the same algebraic moves. So when I look at this, I say, I don't want to deal with the fractions. I don't want to have to find a bunch of common denominators. What am I going to multiply by? 20. 5, 4, and 2 all go into 20 nicely. So smallest number they go into nicely. Multiply both sides by 20. And then you've got to distribute the 20 in, and the question is, do you need to show it or can you do it in your head? That's a big question. So, I mean, and the answer is it depends on how comfortable you are with doing simplification in your head. If you're not comfortable with it, then you're probably going to distribute and go 20 times the negative 3/5 t, distribute. Hey, 20 times 4 is not bad. I'll just do the 80.
I have a question talking about scratch. Is it okay if in the test we have a section on side and then we put scratch and then that's where
I love it when you take your scratch crap over off to the side.
Okay.
And I think on the last work solutions I sent out, I really tried to emphasize breaking the scratch out. I think I even wrote scratch and just pulled it as far away as I possibly could.
Okay.
That's great. What you don't want between equations, and if you read a textbook or pay careful attention to any textbook you've ever seen, if they need to work this out, they don't stick it between the lines and start doing this sort of thing and then pulling it down. They don't do that. And why don't they do it? The question is, I know you guys think I'm a picky SO something, but the question is, why don't they do it? There's always a reason. Nothing is arbitrary. There's always a reason. What's the reason?
I mean, it looks messy.
It looks messy, and when it's messy, what does that make it? It makes it harder to read. It makes it harder for me to read it, and it makes it harder for you to read it, and you're more likely to make a mistake than if you just take this thing over here and say, hey, I don't want to do this. I don't want to do this. That's too much. But I feel uncomfortable with 20 times negative 3/5. Let me pull it over here and write it nice and large. Oh, and I hate not having the 1 under the 20. So I just got to put it there. Okay, well, walk it off to the side and do what you need to do and then bring it back. And now I don't have all this stuff in here making it hard for everybody to read it and follow the work, right? You wouldn't buy a book that smeared it in there because you wouldn't be able to read the darn thing and understand it. So you pull it off, you do it over here because I didn't want to do it in my head and I didn't want to write it down as a separate step because I thought that looked, okay, I'll pop it over here and that's great. Hey, 20 times negative 7/2. If you don't feel comfortable doing it in your head or writing it as a step, bring it over off to the side. Hey, 2 is going to go in there. 10 times negative 7 is going to be, that's going to be what? Negative 70 times t minus, now I've got to do 20 times t over 4, which means I'm going to be dividing this 20 is going to get divided by that 4, which is going to give me a 5. All right, that's minus 5t. So, but just pull it so it's not, that scratch work isn't crammed in here, making it really difficult to read, especially when you got a guy in his 50s who has to wear magnifying glasses on his eyes to see your work. Let's just be kind to old people, make it easy to read. So is that okay? And now once you get it here, do we need to work it the rest of the way through? Yes or no? I need somebody to say yes for me to keep going.
Yes, please.
Yes.
All right, so I'm going to look at both sides and I'm going to say, can I combine any like terms on either side? And over here, the answer is yes. So negative 70 t's minus 5 more t's means I've lost 75 t's. And over on the other side, I've got 42 t's plus 80 of them. Subtract that 42, might as well get the t's over here because that's all that's going on that side. It's my choice. Might as well put them over here. So subtract that 42.
It should be negative 12 t's.
It does look like a negative 12t, but
Did we make a mistake up here? 2 goes into 20
No, on
Yeah,
the
you wrote out 42 instead of negative 12.
over
yeah.
here.
Mm-hmm.
5, 4, negative.
That is
Oh,
negative.
yeah, it is a negative. It just looks like. There we go. How's that? And then that changes that, doesn't it? So did you get my deduction sheet? Did you guys look at my deduction sheet yesterday? So here's a question for you. Let me make that look ugly again. And then what did I do right here? I misread my own handwriting. What's the deduction for that based on the deduction sheet? Because I just lost points, and everybody loses points. I don't know anybody who doesn't lose some points.
1/2.
0.05.
0.05. That's the lowest level deduction that you can get. I recognize brain farts. That's the 0.05 simple arithmetic error doesn't impede demonstrating understanding of the process. Everybody does it, and one of the things that's said in there in that 0.05 error, it says transcription errors is a minor error. And what is a transcription error? It's an error in you wrote it wrong. From line to line, you wrote something wrong, and it's clear that it was a transcription. So it gets marked down because it's not perfect, but it doesn't get hammered because what am I interested in? Process, right? Are you showing me you understand the process? All right, so over here we had a minus 75. So we're going to need to add 12 to both sides, right? And what's that going to give us? It's going to be a minus what, 63? And whoops, then I leave the t off. And then what do you got to do next?
Divide
by negative 63.
Divide by negative 63. And what's the mistake that's going to be the most common one to make?
not flipping the.
Not flipping the sign. And so when you look at that, when you look at my deduction protocol, there's 2 ways you can make this error. And I wrote them both up in the errors I'm going to be looking for. I wrote them both in there because here's 2 ways the error can happen. Are you ready? I'm going to divide by negative 63. I'm going to divide by negative 63. That sign should be flipped right now. I have to flip it right now. Right now it's wrong. But if the student then steps down and they divide it by a negative and they show me they know it needs to flip, that's a significantly less minor, that's much more minor of an error than not flipping it at all. So this is a minor error, but it's got to be marked down because it's a mistake. If I never flip it, that's a major error. There's a big difference between the 2 errors. One is more brain farty, and the other just, I didn't know I had to flip it, which is big. So you either got to flip it the moment that you do it to get full credit, or what I usually do so that I don't make that error, right? Because you write it and the thing's pointing the way that you want it to point, and then you do the division. Now what do you have to do? You got to grab your pencil and erase it and flip it. So I usually don't, when I'm doing an inequality and I see I have a negative, I usually just go from this to this, because then I don't have the opportunity to make that human error where I don't reverse the sign the moment that I do it. So I can eliminate the possibility of making that error just by saying, hey, I know I have to divide both sides by negative 63. And when I do it, I know this is going to be a 1. That's easy. Flip my sign, write my fraction.
If we have to take it one more step so that way we know that we're flipping it, can we make another line and put the negative?
Yeah, if you want to do,
okay.
Your question is, can I do this and then pull down the one more line? And yeah, of course. It's not wrong. It's maybe showing more than what needs to be shown, but there's nothing incorrect about it. It's perfectly fine to do that. And then, you know, what does it say to do? Does it say to put the answer on a number line in interval notation? So if you're doing a number line, folks, and I put this feedback in those common error things, avoid this. 500 tick marks, and I've got tons of you're killing yourself. Just look at that thing and say, what number do I need? Negative 80 over 63. Does it matter where I put him? Nope, because the number line's completely not labeled. He can be anywhere I want him to be. And he's the only number I need on the number line right now. So it's a less than, so it's got to be an open circle, and T is below it. So I've got to point off in that direction, and you guys have to stop doing this because that's going to get marked down on the exam. Graphing your answer on the number line means your answer needs to be on the number line, not above it or below it. So it's got to be exactly on it. And then interval notation, going from negative infinity all the way up to that number. The numbers always have to be left to right. And it's not included, so it'd be an open parentheses there. So anyways, the problem that was asked about, it would be the same concept, but what number would you multiply both sides by? What's the best choice?
32.
32 would work. Is there a better choice than 32?
Could we do
8?
Yeah, 8's the optimal choice. So any number they both go into evenly works. 8 and 4 both go into 32. 8 and 4 both go into 16. 16 would work. But 8 and 4 also both go into 8. And so you want to use the smallest number you can find so that the sizes of the numbers you're working with are as small as they can be. You want to be lazy and keep the numbers small. The bigger the numbers are, the more likely we are to make mistakes with them. All right, so somebody asked about this one right here. And this one was P over P minus K equals C, solve for P. What's the concept? This is the hard one. When we did the literal equations, I said the hardest ones are the ones where the thing you're being asked to find shows up in the numerator and the denominator. When it shows up in the same numerator and denominator, when it shows up in the numerator and the denominator of the same ratio, it's the most difficult situation to deal with. It's also, if you're going on into calculus, going to be, and if you have to go on and take physics, it's going to be the most likely thing that you need to do. So the thing that turns out to be the most painful turns out to be one of the most common things that needs to be done. Especially in the biological sciences, if you're doing population modeling, this shows up in every type of logistic equation that there is. The population variable shows up in the numerator and denominator, and you have to dig it out. So I've set up the same problem. It looks different because I used different letters, but what's the concept? The concept is, hey, solve it for Q. Where's Q? Q is in the numerator, Q is in the denominator. That's the issue, the variables in the numerator and denominator. And the first thing to think about is if you're solving for Q, you're trying to get Q equal to stuff. Who cares what the stuff looks like? It doesn't matter. You want Q equal to stuff. And I'll put them over 1 if you have to think about it. The Q's in the numerator position. When you get q equals, the q is in the numerator position. So when you look at this over here, the thing that has it the furthest away from where you want it to be is the q that's sitting where? In the denominator position. So it's the first thing you got to deal with. You've got to get them out of there, because to get q equals, you need all the q's to be in the numerator. So that's your step one. You start off with your stuff. And you say, this is a problem. The q I want to get solved for is sitting down in the denominator. So I'm going to multiply by the denominator. I'm going to multiply by a minus q. And whatever I do on one side, I have to do it on the other side. And I just put parentheses in here because I'm multiplying and I have binomials, and without the parentheses, I'm wrong. So if I write them like this, that gets marked down significantly. That's a 0.2 deduction on an exam. Because if I write it without the parentheses, only the q and x are being multiplied. And if you put it into a computer algebra system, the computer algebra system will solve it incorrectly for you. And in the sciences, you're not likely to solve stuff by hand. You're likely to put stuff into a computer algebra system. So I'm multiplying those two binomials, so I have them in parentheses denoting the multiplication. I don't even need the multiplication symbol if the parentheses are touching. But the idea is a minus q divided by a minus q. What does that equal?
1.
1. I divided it by itself, so it's just 1. So I get 1 times 2q is 2q. Oh, by multiplying by the denominator, all I'm left with on the right-hand side is the numerator. And then over here, you want to avoid the temptation to distribute a times this, a times that, q times this, q. You don't want to do that. You don't want to just start going crazy with multiplication, because what's our goal? Our goal is to deal with what? Q. And Q's right here. So I'm focusing in on here's what I need right here. So I'm going to distribute this parentheses in. I'm going to distribute into the a. So I'm going to get a times the crap in parentheses. And then there's a minus sign between the a and the q. So I've got to bring that minus sign down. And then it's going to be minus q. The thing I'm trying to get out of the parentheses. I need to get q out of this parentheses so I can get them over here on the right-hand side with the other q. So I'm going to distribute this thing into the q. And I'm not going to worry about multiplying all this stuff out because it doesn't do anything for me. I want to get the q's over here. Now I have minus q times stuff. I can add q times stuff to both sides. Right? Do the opposite. This is subtracting q times stuff, so add q times stuff to both sides. And this crud here can just stay looking just the way it is. There's no point in this multiplying this all out. There's no point in multiplying this all out because do you see a q in there? Is there a q anywhere in this? There isn't. So just leave him alone. Leave him be. He can stay like that all day. You got to deal with the stuff with the q's because we're trying to get q equals stuff. And the reason we put all the q's on the same side is that so they show up as a common factor. And if they show up as a common factor in every term, we can use the distributive property to factor it out. So if I factor q out from here, I'm going to be left with a 2. Here's my plus. If I factor q off of here, I'm going to be left with the x plus y. And what's the reason for factoring it out? It's because now q is connected to this with a multiplication. How many q's do you want? Well, I see one of them. There's one q there, so I need 1 Right now I've got, I don't even know how many that is because it's a bunch of letters. Maybe that's bazillion Q's. I don't know. So I'm just going to step over here. I'm going to pull this crap down and divide by the stuff that's attached to the Q with multiplication. And if you look at this carefully, see the parentheses that I wound up with here? Do I even need it is the question. Do I even need this little set of interior parentheses?
No.
No, don't even need it. So I could write it without those little baby parentheses and it'd be just fine. And you step over here, whatever you do on one side, you do it on the other. And this divided by itself equals 1. 1 times Q is 1Q, and now I have Q equal to some stuff. And the key idea is the stuff that didn't have the Q, I did as little with it as I could, right? I didn't multiply, I didn't distribute the A in, I didn't need to do it. Had I distributed the Q into here, which isn't wrong, had I distributed the Q into here, you know, let's say at this step, let's say I did do a distribution. So I had this. You know, if I distribute everything, minus QX minus plus QY. Now what do I have to do? I have to add QX to both sides, and then I have to subtract QY from both sides. So I actually wind up having to deal with a little bit more. I have 2Q, now I add QX, and then I subtract QY, and over here I have AX minus AY now. What do I need to do with this Q? Factor it off to get, I need to factor it off, and when I factor it off, what am I going to be left with? Bunch of stuff. So the idea is there's no reason for doing all the distribution. Oop, I changed the sign on that, didn't I? I added it to both sides, but I wrote the sign wrong on the interior. You should be a minus C.
I have a question.
Yeah.
Would it be marked wrong if we put parentheses on top at the very beginning, 2Q over A minus Q?
If you're asking, is it okay if I do this?
In the second step where you rewrote it?
Right here?
You were multiplying? Yeah.
There's nothing wrong with that.
Okay.
I mean, when you put a parentheses around something, why are you putting a parentheses around it? You put a parentheses around things to hold it together.
Right.
So like if I have 3 times 2, what's the 3 times 2 being held together by? The multiplication's holding them together. So can I put a parentheses around it? Does it change anything? It doesn't. Multiplication holds things strongly. And usually if you put multiplication on, parentheses on a multiplication, it usually it's not doing anything for you. It's more important when you have a plus or a minus, because the plus or minus holds things kind of weakly together. So here's what I mean by that. If I multiply 3 times 2 times 4, is parentheses doing anything for me? And the answer is no, because the order in which you multiply things doesn't matter. So if 4 times 2 is 8, times 3 is 24. 3 times 2 is 6, times 4 is 20. You can multiply these things kind of any willy-nilly way you want. The problem is if I multiply 3 plus 2 by 4, if I put my 4 times, without the parentheses around the 3 plus 2, what's happening? Only the 3 gets multiplied. And so it's to hold the addition together so that 4 gets multiplied by everything in the addition. I have to suck them together with the parentheses. So it's not wrong to do it here. It's fine. It's not necessary. With an addition or subtraction, when I multiply an addition or subtraction by something, I have to use parentheses to hold them together. That's why up here, I needed to have the parentheses to hold my additions and subtractions together as I was multiplying.
Okay, thank you.
Mm-hmm. Anything else before we walk on to the last one? So this one came up. So I constructed one that, if you look at it, it's just, it's the same kind of beast. And the solution style will be the same on this one. So I've got an and statement. And if it's got an and statement, an and always tells you both things must be simultaneously true. And this is the big thing that is different between an and an or. Or means either thing can be true and it's okay. So the way that I like to explain the difference between and or is kind of from a parent perspective. So I got like 5 kids, and you'll lay down conditions sometimes, you know. Okay, so they ask you, hey, can I go to Susie's house to play? Okay, and and then you're a parent, you're thinking about, well, are there any conditions on that? So maybe the kid has 2 chores they're supposed to do each day. Maybe every day they do the dishes, and maybe every day that kid takes out the trash. So if they want to go to Susie's, I could say a couple things to them. I could say you can go to Susie's when you take out the trash. And now I'm going to connect it with an and, because it works the same way for language as it does for mathematical statements. Take out the trash and do dishes. So the question is this. Susie takes out the trash, but she doesn't do the dishes and she goes over to her friend's house. Is Susie going to get in trouble? Is Susie going to get in trouble?
Yes.
Yes, because what does the and statement mean? It means both things must be simultaneously true for you to get what you want. Your solution is, I want to go to my friend's house, but the and says you need to do both. So if Susie does one of the two, it doesn't matter which one if she does the dishes and not the trash and goes to her friend's house, she's going to get the chancla when she gets home. That's what's going to happen. So as a parent, if you use the or operator, it's different. Take out the trash or do the dishes, and then you can go to your friends. Okay, if Susie only takes out the trash and goes to her friends, is Susie going to be in trouble now?
No.
No, I gave her a choice. I said if either one of these is true, go for it. You're free to do. You're great. So if she only does the dishes and goes to her friend's house, she's not going to get in trouble. And if she does both of them, that's just a bonus. She's not going to get in trouble. So she can do one or the other or both, and she would be free to go. But the moment I replace it with and, it becomes much more restrictive. It means both things must be true at the same time. Otherwise, no solution. You're in trouble. So it works. That's how it works mathematically. So when I see the and connector up there, what it tells me is that this must be true and this must be true at the same time. They must both be true for Susie to go to her friend's house. I've connected it with an and. So I put that in my head, and now I start working on my solution. I have 3x less than or equal to 21 plus 6x, and that's why in the homeworks I keep stressing it's important to put the word, because if it's and, it isn't the same thing as if it's or. They don't mean the same thing. They don't mean the same thing to your kid. They mean something different, and so we have to be careful to use the right word, because the word drives the solution. So now I can work on either one I want. So I'm going to work on this one. I'm going to subtract 6x from both sides. I'm going to get all the x's over on the left. So subtract 6x from both sides. I'm going to get 3x minus 6x is negative 3x. And over here I've got a 21. Okay, what's next? Got to divide both sides by negative 3 to get x by itself. But I know when I divide by a negative, what's going to happen? Pop. I have to reverse the symbol. Is that okay? So I've got x isolated over here. I'm going to step over to this. And I'm going to say, let's see, which side do I want to get my x? It looks like it's going to be easiest to get x's on this side. So I'm going to add 2x to both sides, which is going to give me 5x on the left and 15 on the right. And then I'm going to divide both sides by 5. And I know this is connected with an and, which means this must be true and this must be true simultaneously. If this is true and this isn't, it's not okay. If this is true and this isn't, it's not okay. They have to be true at the same time. I have to do the dishes and take out the trash. I have to do both things. So if I think about this, on a number line, these numbers establish boundaries. So again, I'm not going to put a whole million tick marks. I'm going to say I've got a negative 7, which is to the left of 3 on the number line. And I want to graph the solution. I'm going to go ahead and get a different... No, I don't want the eraser. Come on. Pointer options. Pointer. Oh, come on. And ink color back over into red world. So then I want to look and I want to identify on the negative 7, does it have the equal to component? And it does. So I know at negative 7, I've got a solid boundary. And I don't have the equal to on the 3, so 3 is a boundary on the solution, but it isn't part of the solution because x can't equal 3. So it's a boundary, but not part. And because it's not part, I put an open circle denoting I'm on the boundary, but I'm not part of the solution. And I need to think about this. So if x is greater than negative 7, that would mean x is a kind of thing that starts at negative 7, and to be greater than or bigger than negative 7, x would need to be going this way. And then I look over here, I see x is less than 3, but to be less than or smaller than 3, I would need to start here, and I would need to be going this way. And the key with the and statement, is that both things have to be true at the same time. And where is the only place that I can be bigger than negative 7 and smaller than 3 is to be between negative 7 and 3. It's the overlap in the two arrows. The overlap between the two arrows is the solution, because the overlapping area is where x meets both criteria. And an and statement tells you that the x has to meet both criteria to be true. It has to do the dishes and it has to take out the trash. You usually don't write the arrows above and below. That would be bad style. So do it on the exam if it helps you think about it, but then after you do it, get rid of them, because on the number line is the solution. And the moment I see that it's a line segment, where's x? X is between the two numbers, which means I'm going to be able to write this as a 3-part inequality, because I can take this here, the and statement can be compacted, because -7 is a boundary, and to the right of -7 on the number line, 3 is a boundary. And what lives between -7 and 3? X does. Where does x live? Between them. This symbol needs to point at the -7, and it has an equal sign under it. And this symbol needs to point at the x. And I have a 3-part inequality with x between the two boundary numbers, because that's where x lives. On the number line, x lives between the two boundary numbers, not to the right and not to the left. If all you do is change this thing to or, it completely changes what the graph of the solution would look like. In interval notation, quickly though, this would be x is an element of, -7 is included, so I have a square bracket, comma, go all the way up to 3, stop there, don't include the 3, so it's a parentheses. If you change this and to or, if you changed it to or, the solution would completely change. The solution completely changes. Change it to or. To be greater than or equal to -7, where do I need to be? Anywhere to the right. Or to be less than 3, where do I need to be? Anywhere to the left of 3. With an or statement is true if either of the two is true. If I take out the dishes, good. If all I do is take out the trash, good. If I do both things, good. So anywhere where either one of these two things happen is a solution. And now what do you see? The solutions are everywhere. The whole number line is a solution, because it's not, because it doesn't have and, it's not just the overlap, it's anywhere where there's red arrow. That's a solution. And that actually covers every number. So if you change it to an or, you'd actually get, hey, x can be any number you want. And it will be smaller than 3 and bigger than -7. There isn't a number on the number line that isn't one of those two things. So the and or, differentiating between an and an or is really important. And then that's why in the homework, when I send out those common errors, when you have an or statement and you don't put the or between the two, I write it in there because it matters. Is it an or is it an and? And you have to show that you know the difference, because they don't mean the same thing. Is that all right?
Yes, thank you.
On the exam, if we do get a 3-point inequality at the end of the problem, will we have to write it out as a 3-point inequality?
Yes. So if you look on the practice exam, I give a list of things that you have to do. And one of them is, if it can be written as a 3-part inequality, you must write it as a 3-part inequality. It says things like, don't convert fractions into their decimal representations. So if you have a 3/2, it stays 3/2. Don't make it 1.5. Show me that you can deal with fractions, because that's a part of this course as a pre-calc course, is demonstrating that fractions don't bother you anymore. So I'm not going to give you, I will not on the exam give you any of the funky cases. So there's the funky cases where the and isn't a 3-part inequality. There's funky cases where or, there's funky cases, but in science, 99.99999% of the time when you're working with inequalities, say in physics or chemistry, if it's an and, it's always going to be a three-part inequality, and on the number line, the answer is going to be a line segment. The things are going to be living between the two boundaries. And if it's an or statement, and you get the two boundary numbers, the middle isn't going to be a solution, and the solutions are going to be pointing off to plus or minus infinity, and the middle will be missing with an or statement. With an and statement, it's always going to be a three-part inequality. The middle is what is the solution. And when the line segment or the middle is the solution, it's a three-part inequality. X is between two numbers. When it's an or statement, X isn't between two numbers. X is either to the right of one of the numbers or X is to the left of one of them. So you can't write it as a single statement. It has to be the union of the two disjoint or non-overlapping solutions. And those are in application problems in the sciences. That's how it works. So mathematically, we can construct problems that don't behave nicely. And in ALEKS, they like to feed you problems that are like that, where you have to deal with these one-off cases. But I would say from a practical standpoint, in the real world, when we're doing chemistry and biology and physics, we don't run into those one-off situations. It's always really straightforward. You're either between the two numbers or you're to the left and the right of the two numbers. And that's how it works. So on the exam, I'm going to feed it to you the way that it happens in the real world. If it's an and statement, you need to recognize it's an and statement, and it will be a three-part inequality. When you get down to here, you'll be able to compact it. And if it's an or statement, it will be impossible to write it as a three-part inequality. And the moment that you try, you know that you're wrong, because an or statement is always going to be a union between two non-overlapping intervals. Every time. Because that's how it happens in the world. Anything else?
On the test, on the number lines, are we able to use like a colored pencil or a pen?
You don't have to use a colored pencil, but a colored pencil certainly makes it easier to write the solution. So my suggestion is that you do have a separate color so that it's easier for you to read, it's easier for me to read, it's easier to see what the solution is. And I think on the answer keys I sent out, I tried to do it in a separate color to make it easier for you to read it. Otherwise, you're sitting there trying to make it really, okay, I'm using pencil on pencil and I'm trying to make it blacker than the black. And it's, you know, I mean, it works, but it doesn't work well. Anybody else? All right, I'm gonna stop the share and end the meeting. I did record this, so I will upload the recording into YouTube and send the link out in Remind.
Thank you.
You're welcome.
Thank you.
Yes.